Hey everyone, and welcome back. Before we begin here today, please make sure that you like and subscribe because it really does help out our channel and it also helps us reach others in need of assistance with the topics on the PE civil exam. So this will be our first problem in the geotechnical series, and we're going to be looking at soil properties here. So the question states, a clay pot has the following Atterberg limits of liquid limit equal to 60, plastic of 40, and a shrinkage limit of 25. Using mercury submersion to determine the pat volumes, the clay pat shrinks from 15 cubic centimeters down to 9.57 cubic centimeters when the moisture content is decreased from the liquid limit to the shrinkage limit in the Atterberg test. The clay's specific gravity dry is what? So we have our four options here. So it's obviously going to be 2 point something. So a little bit of work to get through this one, but let's get started. First, we want to determine what our water volume reduction is. So I'm just going to call that delta MW for our water volume reduction. And that's simply going to be how much did we reduce here? How much did we shrink by? So it'd be 15 cubic centimeters minus off the 9.75 cubic centimeters, which gives us 5.43 cubic centimeters there. So since 1 cubic centimeter of water has a mass of 1 gram and the mass loss is 5.43 here, the fractional mass loss, which is our dry basis, is, well, we're going to call that delta W, which is our fractional mass loss. And that's just going to be, well, from our liquid limit, which is what we said we're going to the shrinkage limit down here, which is right here. So that's going to be 0.6 subtracting off 0.25. And that gives us a total fractional mass loss of 0.35. So essentially what we have here also, what I was stating earlier is that the mass of water is 1 gram. So the mass loss here is 5.3 grams as well as cubic centimeters. So what we're going to have is our solid mass, MS, is going to be our delta MW divided by our delta W. So we would have 5.43 grams due to that conversion I stated earlier, divided by 0.35, and that gives us 15.5 grams in total of our solid mass. So next thing we need to determine in this series is our water volume shrinkage limit, and I'm just going to call that VW, and that's going to be our moisture content multiplied by our MS that we just determined, divided by our rho W, which is our water there for the 1 gram per cubic centimeter. So our moisture content will be at the shrinkage limit, which is what we are looking at here. And that was 0.25 for our moisture content times our MS, which is our solid mass of 15.5 grams. And then we're going to divide by, well, 1 gram per cubic centimeter here. And we get a total volume of 3.875 cubic centimeters. All right, moving right along here. So we must understand that the volumes determined from the mercury submersion are combined water and solid volumes. At the shrinkage limit, there are no air voids as the clay is saturated. Therefore, the volume of the solid at the shrinkage limit is going to be this. It's going to be our 9.75 cubic centimeters, which is what we had up here, subtracting off what we just determined to be our water volume at the shrinkage limit of 3.875 cubic centimeters. And this gives us a total of 5.695 cubic centimeters. So this will be our volume of the solid at the shrinkage limit once we subtract out our water volume at the shrinkage limit. So our overall density is going to be this. Our overall density of the solid is going to be rho is equal to our 15.5 grams divided by what we just determined as 5.695 centimeters cubed. And that gives us 2.72 grams per centimeter cubed. So that would be our dry density. So now we have to determine our specific gravity, which is basically going to be this divided by 1 gram per cubic centimeter. So it's going to be basically 2.72 grams per cubic centimeter divided by, well, 1 gram per cubic centimeter. And that gives us 2.72 of our dry specific gravity. And if you look at our answers here, because we have our SG is, I'll just write right here, 2.72 out of our dry specific gravity. And if we look at our answers here, we don't really have anything exactly 2.72. So you have to watch out with the PE exam problems like this. If you've taken the FE exam, you realize this, that they're always going to have answers that are going to be a little bit off of the final answer you get. And you always have to pick the one that is the nearest to it. So in this case, we have 2.72. Well, 2.7 is our closest specific gravity answer that we have here. So we're going to go with answer D as our final answer for this problem. So I hope this video was helpful. And if you want to see more problem solve this variety, please check out the other videos on our channel. Also, if you've done so already, please like this video, leave a positive comment below, and subscribe to the channel. Also, good luck on the PE exam. Thank you for watching, and I hope you have a fantastic day.